Hello, for this worked example, we are working with a ladder that's kind of propped up in a corner. So this is the wall, the floor, and the ladder itself between A and B. So the base of the ladder is slipping out at a speed of 2 meters per second. We want to know, based on its current orientation, what is the speed of the top of the ladder? So this doesn't look like our robotic arms problems, but we can still solve this using relative motion analysis. So I always need to start at a point that's not moving. So that is neither point A nor point B. They're both going to be moving. Instead, I'm going to use point O as my base. So what I'm going to do is think about this as an arm that is going from point O up to point A and then down to point B. So O, A, B. All right, so for each of these, I also have the angles, so or the directions as well. So if I'm going from O up to point A, my R direction, UR1, would be going straight up. U theta 1 would be going out this way. Let's make room for that. So going O to A, and then A to B. So I'm also going to make room for my R and theta direction down here. So UR2, U theta 2. All right, and so direction-wise, this is going to be a 3, 4, 5 triangle. So this angle up here, I could figure that out. It'd be the inverse tangent, or the tangent of 3 over 4. With that, I could figure out that these two angles here, so this angle here would be the same as this angle up here. And then I have 90 minus that. Basically, in the end, I can figure out that this angle here is going to be 53.13 degrees. This angle here is going to be 90 minus that, so it's 36.87 degrees. This is also 38.67 degrees. All right, so that's my angles of R and theta directions. Overall, the equation I'm going to use for this is the velocity of point B with respect to O. That's this velocity here, 2 meters per second in the x direction, is going to be equal to the velocity of point A with respect to O plus the velocity of point B with respect to A. All right, so I know a little bit about the velocity of point B. I want to know the velocity of point A with respect to ground, because that's the downward velocity at the top of the ladder. And then B with respect to A. I know it's rotating, but one thing I do know is that the length of the ladder is not going to change. So I can treat this like a simple rotation here. All right, so let's break this down into components. So I'm going to take this equation here and plug in the values that I do know. So put that down. All right. So the velocity of point B with respect to O was 2 meters per second in the positive x direction. So I'm using the I unit vector there. All right, so A with respect to O, well, what do I know about that? So it's going straight down. So OA is not rotating. It's not extending either. It's doing the opposite of extending. So rather than use R theta dot, what we're instead going to do is use R dot in the R direction. So this is going to be R1 dot in the UR1 direction. All right, so I also am going to add the B with respect to A. It's going to be simple rotation, so the length of the ladder is not changing. So it's going to be R2 theta dot 2 in the U theta 2 direction. All right, so what I can get from this, if I break it down in, if I put in the actual directions and some of the numbers, so I'm going to get 2, and the I direction goes this way. So R1 dot, let's call this 4 meters. This is what's changing, D. So it's going to be D dot is R1 dot, it's the rate of change of that length. And then the UR1 direction, that was just going straight up. All right, and then R2 theta dot 2. So how long is R2? So 3 squared plus 4 squared will give me 25. Square root of 25 is going to give me the length of the ladder AB is going to be 5 meters. So the R2 is 5. Theta dot 2, I don't know that. So it's the rate of rotation of the ladder itself. 2. All right, and then the U theta 2 direction. So that was going 36.87 degrees up. So this angle here was 36.87 degrees. All right, so this can be broken down into X and Y components. So in the X direction, I've got 2 is equal to, well, there is no X component to this, it's going straight up, is going to be equal to 0 plus 5 theta 2 dot times the cosine of 36.87. All right, in the Y direction, we're going to have 0, so this has no Y component. That's going to be equal to D dot plus 5 theta 2 dot times the sine of 36.87 degrees. All right, so I can take this X equation and solve for theta 2 dot, so it's the rate of rotation of the ladder. Once I have theta 2 dot, I can plug it into my Y equation, find D dot. So that's what we're going to do. And if I plug that in, what I'd get out of theta 2 dot is this is rotating at a rate of 0.5, and the units on this are going to be radians per second. So that is theta 2 dot, the rate of rotation of the ladder. All right, so that gets plugged in here. So 5 times 0.5 times the sine of 36.2. D dot is going to be equal to negative 1.5, and the units on this are going to be meters per second. So this is actually basically going to be my answer. This is the rate at which D is changing. So D, this 4 meter length, is going down at a rate of 1.5 meters per second. The velocity of point A is going to be 1.5 meters per second downward, since point O is not moving at all. All right, so VA is 1.5 meters per second downward. All right, so that's all we have for this worked example. Thank you for watching, and I hope to see you again.